Hello everyone, welcome back. This is Engineer Hussein, and in this video we'll be looking at some physics problems that were presented. So in our case, we're having a problem that is as follows. We've been told that the person travels by car from one city to another with different constant speeds between pairs of cities. Now this person drives for 30 minutes at a certain speed, which is 80 kilometers per hour. Then again 12 minutes at 100 kilometers per hour, and 45 minutes at 40 kilometers per hour, and spends 15 minutes eating lunch and buying gas. Okay, so let's see what we can do. We've been told to draw a speed time graph to represent the motion, determine the average speed for the trip, determine the distance between the initial and final cities along the route. Alright, so before I begin solving this, do not forget to like and subscribe to the channel. Alright, basically when it comes to A, in A, we need to draw a speed time graph to represent the motion. Let's understand what's going on. So we have different speeds being covered in different times. So let's try and collect some data. So we have different speeds being covered in different times. So the first speed that she drives was for 30 minutes. And this 30 minutes gave her speed of 80 kilometers per hour. So much into the force. Anyway, so the first time of 30 minutes, the speed was 80 kilometers per hour. And then it was 12 minutes that she covered about 100 kilometers per hour. Then again, there was 45 minutes that she covered about 40 kilometers per hour. And then again, she had to spend like 15 minutes just to eat lunch and buy gas. So basically, these 15 minutes, she did not cover any speed, or she did not really have any speed. So we'll just say 0 kilometers per hour. So we have the speed and the time. We have 80 kilometers per hour, 140, and 0 kilometers per hour. So basically, when it comes to you drawing a speed time graph, the first thing you need to bear in mind is that you have to balance the units. As you can see, you're having kilometers, 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 and kilometers at each and every point of the speed. And then again, you're having hours like on these other parts. So if you look at your time is in minutes. So it's best to say that we need to convert either the hours on the speed to minutes, or rather just convert the minutes side to hours. So either ways, so long as we balance, maybe if we have like kilometers per minute on the speed part, and then we maintain the minutes on the time part, we can draw our speed time graph. But it's quite easier to do it by converting the time you have this side to hours. So now we know that basically 1 hour is equivalent to 60 minutes. So to convert whatever minutes we have into hours, all we have to do is to divide by 60. So minutes to hours, all we have to do is to say, so to get my x hour, I just have to divide my minutes by 60. So I'll get the hours I need. So basically, if I divide 30 by 60, I'll be having about 0.5 hours. If I divide 12 by 60, I'll be having 0.2 hours. If I divide 45 minutes by 60, I'll be having 0.75 hours. And if I divide 15 by 60, I'll be having 0.25 hours. So basically, I expect you to follow through with your calculator as I am solving this as well. So we have our hours balanced with hours. So we can now attempt to draw our speed time graph. So it's speed versus time. So it says speed versus time. So we know we'll have our speed and the time. So I'll draw it a bit small, but just try and follow. So speed, we know that the speed is in kilometers per hour, and then the time is basically in hours. So all you have to do is to look at the speed and see the intervals you have. So you know at this bottom here, this is the origin. So this is where the 0 point is. So you have 0, 40, 80, and 100. So you can just create your own scale along the y-axis, which represents the speed axis. So you can just create your own scale. You know it's 0 to 100. So you can just say, okay, this is 0. At a convenient point, you say, okay, this is 40. Another convenient point, you say, okay, this is basically my 80. At another convenient point, we just choose this to be 100. Then try to read what's going on. So at the time 0, we can't really start at time 0, or let's say at 0 kilometers rather, because the journey starts from this point. It starts from 80, then it keeps on going like that. So we need to read it from the top going down. So we know that she drives for 30 minutes at 80 kilometers per hour. So we know it's about 80 kilometers per hour in 0.5 hours. So you stand where she was starting from, the speed. So she started at what? 80 kilometers. So 80 kilometers, we know that she has to maintain this speed for 0.5 hours. So we can put a mark and say 0.5. We know these are hours. So the person is going to move until she reaches that point. So that is the speed of 80 kilometers. 80 kilometers per hour in 0.5 hours. Then again, what happened was that the speed changed. We have different changes. The speed wasn't constant. It was changing with respect to time. In the first 0.5 hours, the speed was at 80. Then again, at 12 minutes, the speed was, after an increase of 12 minutes, the speed was at 100. So now, from 80, the speed changes to what? 100. Now, at the speed of 100, how long did this person move with the speed of 100? It was about 0.2 hours. So if you can remember, look, you are moving at the speed of 80 for 0.5 hours. Now you have reached 0.5 hours, and then you decide to increase the speed. So what you would do is that you increase the speed at 100 and move at that speed for 0.2 hours. Now, simply because your previous speed was 80 at 0.5, you then have to add 0.2 to 0.5, and you'll get the time that this 100 was maintained, and that was basically at 0.7. So you move with this at 0.7. So you move with this for 0.2 hours, but from the initial to that point is 0.7 hours. Then again, the person changes the speed to 40. So reduces the speed, now goes to 40. Now, for how many hours was this 40 maintained? So this 40 was maintained for 0.75 hours. So if I add 0.75 to 0.7, I'll be having basically 1.45. So it was maintained for that long. Now, basically, the person did not cover any, or did not have any other speed the time this person was eating lunch and buying gas. So there was no speed that changed at this point. It was just that speed that was 40. But the time wasn't finally at 1.45. The final time was when you add 0.25 to what you already have. So basically that would be 1.7. All right, so now I really want you to understand this. So this is how you can basically understand speed time graphs. Always visualize the question as though you are the one in it. So basically imagine yourself in a vehicle. You're going somewhere, and then you have a speed. You're moving at the speed of like 80 kilometers per hour. Now you move with that speed for 80 kilometers per hour in 0.5 hours. After some time, maybe you tell yourself to say, anyway, maybe I'm running out of time. Let me increase my speed. Okay, so you change at that time 0.5, you decide to increase the speed at 100. So you move to 100 there. Now when you reach the 100, you then maintain that speed for 0.2 hours. But now from the point where you are, which was 0.5, moving to 0.2, your time now will be at a sum of 0.5 to 0.2, which gives basically 0.7. So that's how long you maintain the 100 if we consider it from the origin. But from where you were to the next point, we basically know that that's just 0.2. And then the same concept is applied throughout. So that is how you come up with your speed time graph to represent the motion. All right, so now B says determine the average speed for the trip. So the average speed is equal to the total distance, rather to say total distance over total time. So we can do up a data and look for our total distance. So since it's a speed, the area under the speed time graph represents the distance. So you have portion A, portion B, and portion C. So for portion A, you have the shape of a rectangle. So you say L times B. So the length is basically 0.5. B multiplied by 80, giving you about 40 kilometers. Then portion B, same thing, L times B, it's a rectangle. So you can get the 0.2, which is the difference between 0.7 and 0.5. Then multiply it by 100, and you basically get 20 kilometers. Then portion C, same L times B, because it's a rectangle. You do up 0.75 times 40, which will basically give you about 30 kilometers. So these were the distances. Now to get your total distance, let me just say TD, you really just have to add up all these 40 plus 20 plus 30, which basically gives you 90 kilometers as your total distance. All right, so this distance is even the distance from the distance you have from 0 to 1.7. So from all the cities that you are having. Then to find the speed average, you set total distance, which is 90, divided by total time, which is 1.7. If you compute this, you have about 52.94117647. So if I decide to round off, speed average will give me 52.94. Remember, this will be in kilometers per hour. So basically that will be our speed. Now, if you look at C is asking us to determine the distance between the initial and final cities along the route. So the distance between the initial and final cities is the total distance we just found. So we just say that the distance T is equivalent to 19 kilometers. All right, thanks for watching. Don't forget to like and subscribe. If you have any queries, you can reach out to me on WhatsApp on the line 077 149 5252. Remember, slow progress is better than no progress. And let's strategize before becoming a statistic. Let's try and push for that A+.